there was this stage when we finally got a good-sized computer, and we built a special workstation for it that was used quite a bit later. It cost us, I think, $90,000 in the 60s money to get it. And so with that and the 13 hours a week we had on the computer, not a timeshare computer and not a very smart one. So we started building the very first stages of our well, I guess you'd call it a word processor to start with. The one we dubbed to be NLS for online system. And incidentally, people says, well, wouldn't that be OLS? And my remark is, oh, we also had an offline system where you could say what you wanted to edit and change on a teletype that would punch tape and then feed that to the computer and it would do the work for you, see. So this was the online system, NLS. And so as that progressed, and this followed our experimenting with screen selection devices. So we had the mouse and working. And so we had a set of commands we could edit and move and jump and move things around in just a very basic way. So then we thought it would be valuable to show people that in the movies. So we got a 16mm mover camera, and the way we'd have to take the pictures of the screen, which was about this big a round screen, and we'd put a shroud over it and over the camera, and then I'd be in the way if I sat there, so I had to get down on my knees and reach up like this to run the system while the camera was overhead. So at the same time, I found a special video or a film projector. These are both 16mm films, and so this projector could run at normal speed or any subordinate speed, partial speed, and it also could step along one frame at a time if you wanted to, so that we could then show a movie of what we would be doing and piece together different segments of it so it would just be a continuous. And then, because nobody was using interactive computers like this at all, you couldn't just sit down and run it. So what you'd have to do is use that special projector and say, okay, here's some text one wants to enter, and here's what's going to happen. So click, 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 click to step through it. See, we select this. See, now we've changed the command. See, now we hit operands, and bingo, it changes, and go step by step through a sequence, and then say, let's back up to the beginning, and we'll run it at normal speed. And this was the thing that no one yet had ever put together, the kind of command sequence and speed of operation that you could just da-da-da-da-da-ping, you know. And so it just, universally, when we'd show it in that sequence, it would have a heavy impact on people. But one especially important historical time was Bob Taylor, who was the manager of the ARPA's single one office of Information Processing Techniques office, like that, had a meeting with the interested people, including principal investigators and other kinds of people around that were interested in this. And it was at MIT, and so we all congregated, and it was like the middle of the day. And, well, you know, it's not a really fixed program for it. Well, what do we do? They said just that different people sort of said what they thought they could do or would like to see. And he asked me, and I said, well, I have a movie. And something to show a movie would just satisfy everybody's need and not have to get started right away. So I ran that movie. I did it by starting, going through the steps, and then ran it full tilt. And it was obvious that it had a really significant impact. These are guys that have been talking about time sharing and interactive computing, etc. And they were part of a team that in 1963, there was a whole summer session there about time sharing in MIT. And every one of us had had a chance to give an hour's talk. And in my talk, I could just tell they were getting restless. And when I came down and said, well, I think that interaction time is going to be important because you won't start feeling satisfied till a lot of the interactions get down to like 1/10 of a second. And the room just chilled and snorted, and I'd lost an audience. See? So some of these guys, the later, when I was putting on this film, were from that group or something, and it just really tickled me the way it was obvious that they were impressed that this kind of speed, flexibility of doing it and seeing the reaction go, and just nothing like that had been in their minds. And so one outcome from that at the end of the day, when we had some wine or beer refreshments or something, Bob Taylor came over to me and sort of grinned and said, "You know, the trouble with you, Doug, is you don't think big enough." And I almost collapsed. He says, "Well, what would you really want?" "Oh," I said, "that's pretty clear. What I'd really like is a nice full-size time-sharing system dedicated to my lab that we could use to do all of our work all the time in it and learn how." "Oh, well, write a proposal." So like 5 or 6 months later, after a lot of go around of people involved, somehow NASA got involved in that. We got the computer, and after 3 or 4 months, got basic stuff running. So that probably basic things running on it was probably early 1968. So we had that time sharing system working in our lab by the early 68, and somehow about the first 3 months or something in there, I heard about that there was the planned fall joint computer conference, and in those days there were only 2 computer conferences, one in the fall on the West Coast and one in the spring on the East Coast, and they were called the Fall Joint Computer Conference. And so that, all right, that I just got very bold and sort of proposed to the program committee that they give us a full hour-and-a-half session, and we put together a video, a screened presentation, and well, that was pretty unusual, and they were good committee. So they actually sent a subset of the committee down some weeks later just to look at it and talk to us, etc., to see if this, that was a pretty big request we made. So they looked at it and approved, but all the way through, it was, everybody was sort of, the committee, etc., the people who ran the conference, and I was on edge, and my crew was, and the government was sponsors. But it was just a marvelous job. I put together a scenario, and between my chief engineer, Bill English, and the chief programmer, Jeff Rulison, they just did fantastically to get it really working. And in the engineering side, we had to build our own homemade modems so that my workstation up there on the stage that I was running could communicate back to the computer. And then to get the video response, our computers, the screens on the computers were generated by video cameras in the computer room, and looking at very small high-resolution cathode ray tubes that the computer could write on. And so normally then that video was just cabled out to our working spaces to have individual screens. And so then we had to rent from the telephone company 2 video lines from SRI up to the city, and that required them coming and establishing video dishes up on the roof of SRI, a truck up on the skyline up on top of the mountains partway to the city that these were beamed at. That one had 2 dishes watching this and 2 dishes to retransmit, and on top of the conference room where the conference building was were 2 more receivers, and they piped it down. And then Bill English built a platform about 3 or 4 feet high, and then he shrouded it with canvas so it could be private back in the back of the conference space itself. And as 2 video feeds came in from down at SRI, and 2 from up on the stage where I was. There was one video thing mounted on the workstation that presented to watch my face, and another one overhead that could watch my hands. So we had those 4 feeds he could mix and switch between. And then there was an audio line back down to the SRI when he could sort of give people directions about, hey, move that camera closer, do this or that. And but they fixed it up for me too, that I'd have an earpiece that I could hear what was going on. But oh boy, was that ever confusing, because there'd be people say, oh, hey, wait, I'm not ready, and all that would be going on in my ear when I'm supposed to be giving the presentation. So there were a couple of times I just made such funny boo-boos at the talk. So all that ended up, just so many things could have gone wrong, and they didn't. I made a few boo-boos, and it was a kick, so it really worked beautifully. I think everybody felt pretty skeptical or leery or worried about it when it was first proposed, me included, because it really was kind of an outlandish gamble. But more and more as it got going, they just did terrific. The whole team. At least there were 2 or 3 of the people who had to take a turn at sitting at their workstation and demonstrating something. So what was their workstation, we could type that up on one video channel and their faces on another, so they could be superseded whoever we wanted to. And it was fixed up so that the cursor from my mouse could be on the same screen as theirs, and so that I could point to something and ask them a question about it, and they could respond and answer. And well, that presentation just was the preparation for it was 6 or more months of preparation. And as it got to move on, more and more sort of excitement, and I felt a real focus in the team. And it really was great. And then afterwards, some of them came up to the city right away. So we had a reception after that day, or I can't remember when it was, but then they could be up there and people could meet them. It was just terrific. Anyway, we all just felt glowing afterwards. The vision I've been pursuing for decades is that mankind has really a need to improve its capability for understanding very complex dynamic situations and coping with them. And this is a collective capability that has to be done, and so that's been my goal. How do you improve that collective capability? And early on, I sort of generated the term augmenting, how we augment this capability, and that realizing there's actually a whole augmentation system with many, many components in it that support that capability, complex capabilities. And so it's a complex challenge to improve such a capability throughout most of mankind's environment. So that augmentation system and its capabilities and the ways to evolve the segments, parts of that system that contribute to that particular capability, is a real challenge. So it's unfolding, unraveling that, and getting a picture of the things one can do about it for the early years. And everything I've done since the early 60s has been, all right, trying to find practical implementations for making that evolutionary change start taking place. One of the difficulties of carrying out these thoughts has been that when the computer started to invade our society, everybody had great ideas about what the computer would do. And in my picture, the computer is sort of an extensive part of the emergent technologies that have supported our knowledge work, We're back with the invention of the alphabet, etc., and the printing press, and schools, and many things. So much evolution takes place besides that technology. So it's just a factor, and you can't just plug something brand new technology into society and then expect to derive the consequence improvements you're hoping for. So talking about an augmentation system gives a perspective about technological things that really are quite different from the way the business world and the popular world sort of has been viewing it. You know, for instance, search engines. And now, bingo, you can find all the references to given topics or something in a very, very short time. Well, that's very interesting help. But that's only part of the whole problem. Then you go find them and look at the different references and start comparing and searching and integrating what you're finding into an answer for what you were pursuing. And so the search is just one part of it. So you're augmenting one kind of capability, but that's only a component capability to the whole thing of developing that understanding of what situations are. The work I put in the early 60s of thinking about what I called an augmentation system. And it starts with looking at the whole infrastructure of capabilities that it takes to process and accomplish certain tasks and domains, something like this. So just bringing in one new capability really unsettles the balance of it all, and so other capabilities have to start shifting and changing in order to match with that. And so it's an evolutionary thing. So businesses' orientation of coming in and solving one problem at a time, and then how soon the customers that are using that see that they can take a need there, is a evolutionary process that will eventually get there. But if you feel like the potential value to organizations of any size of getting there faster to have these collective capabilities is very high. Supporting the concurrent evolution of all these changes, because a change in one capability looks for a change in others. Improving capabilities isn't all just putting new technology in there. It's skills and change, customs and practices, the vocabularies, etc., all changing. And if you look at all of that sort of thing that's existing today as contrasted to 10 years ago, you realize that the people, what they were talking about, technology coming in like this, wouldn't fit in today's. They're not enough. So it's that evolution of all these things proceeding in their concurrent evolution that says, hey, if we would like to evolve that faster in order to get the kind of capability that the existing technologies could provide if we knew how to apply it best. As one thinks about this augmentation for a while and then thinks about how many changes are going to come about besides the introduction of radical technology, you realize that there's no way that you could guess today and bring out the technology that would best fit for 5 years from now the way the organizations and the ways of working and thinking, etc., would evolve, and the kind of human capabilities to interact and use the technologies can evolve. So there's just no way you can reach ahead. That the best way is to facilitate the evolution. One big important thing is to get away from this feeling that it's got to be easy to use. My top level challenge and goal is to improve as much as possible mankind's capability for solving complex, urgent problems collectively. And I've come to believe firmly that in order to do that, we have to take into account the entire augmentation infrastructure. Well, this thing I call an augmentation system ends up a very fascinating total thing. It's oriented around capability in this model. And people are always trying to improve capabilities to do your business better, etc., etc. Along with improvement, that's an associated evolution of that augmentation system. There's hardly any way you can make a significant improvement in the large scope capabilities without that. So particularly the goal I have about, we so badly need to improve our collective ability to understand and cope with complex situations. That's very complex. And yes, you can bring about a new tool will come out and that'll help. The augmentation system in our society, you need to orient a particular augmentation system around the capabilities that you're concerned with. So for the kind of capabilities in our knowledge work, etc., it's been evolving very much in the last decades, and the evolution is going to continue. The thing is that there are ways to facilitate that evolutionary process so that the kind of goal of really collective capability can be accelerated as faster than it will be just by the current day of business-driven things, etc. Okay, and then an interesting strategy emerges of that is the kind of capability we're trying to improve is the collective ability to cope with complex challenges. Well, a complex challenge is how we can improve our collective IQ. So you said, oh, as fast as we begin to improve that, let's be sure to apply it in the solution, in the pursuit of the better improvement. So the better we get, the better we're going to get at getting better. And I've chosen the term bootstrapping, like lifting yourself up by the bootstraps, to sort of characterize that one. So that's why I named the Bootstrap Institute and the Bootstrap Alliance. I think a really problem in this thing is to raise the awareness of the potential for making significant improvements in that capability, and the awareness of how much value that would bring to society, and in fact how much almost desperate need there'll be for that improvement, else probably some kind of total crash. Well, it's hard to picture a better and more important goal for our mankind, our humankind, than getting better, if we can, at the way of collectively understanding and coping with complex problems. Well, it's becoming ever more apparent that we have some really, really serious, complex problems, large scale, etc., in our world, and that it's very important that we start finding better ways, competent ways to solve them. It's important that we find better ways to understand the situations, and including the situation of involved in the solutions, and how we best can cope and pursue them. It's not enough just to, it's sort of like the global warming, it's not enough just to understand what's happening. You got to understand what can we do about it. And then when you know what you can do about it, you have to understand what resources you have for applying it towards that solution. And then as that goes on, it raises all sorts of other complex problems, which any pursuit actually will. So understanding the situations as they evolve is important. And so it's not just a one-shot scientific study of a given situation. Well, for systems of any complexity, and trying to arrive at an understanding of them, there'll be disagreements. Well, that's probably not what it caused, or is that true? So the kind of real augmentation process has to include all of the untangling of the disagreements and all of the placing of facts, and then how these facts relate. And so there really is sort of explicit structuring of arguments that are being done in some places with computer help. So that's the kind of thing that would be there. So you can look at all the things, follow the chain of what supports this argument, what supports that, and pretty soon come to conclusions about what's the probable best side. So the computer can help a lot, but not by coming in and giving you the answer, but by showing you the logical structure. So much better. And then computers will get smarter and smarter, of course, about, helping you find out whether or not a given chain of rationale and fact-finding is better than another. Reasonable people can look at the same set of facts and disagree upon what the implication of the understanding is. And digging into finding the relationships, etc., is necessary. And eventually, reasonable people need to find, oh, that's probably right, or something. So you need to leave that trail of reasoning that'll be in there, so anybody can come along and have new questions and objections, and those would then get parsed through and dealt with, and they may change what the resulting decision was about what was the real situation at any given point. The processes reasonable people can go through in order to find out and come to agreements and terms and understand, those processes are all open for augmentation. And some computer help, and some about the processes they use, and the computer help can actually start diagramming the relationship between different facts and considerations, etc., to offer help. So these are things that are just there to evolve and evolve into our way of working. We need to evolve the augmentation system involved in this situation, so it gets more and more effective for reasonable people to come to an understanding that they agree on. This is something that is just not gotten into the dialogue out there, the things about that augmentation system, and that it's really capability that was the central focus that will help drive all this. Well, there are many, of course, an innumerable number of identifiable capabilities that are involved in the world, and so the collective capability is even more complex than individual capabilities. It involves lots of people being able to do lots of things, and as you improve that, it's complex. One can only look and say, well, the invention of the alphabet and the subsequent invention of the printing press and all of the things that went about with it to get to be so that we have books and reading and communication that way in school systems, huge amount of social and some technical and business evolution. So there's anybody that at the time dawn of the alphabet or the dawn of the first printing means could have anticipated all of that. But how long did it take? And today we have situations where the associated technologies can evolve so much more faster, and they offer so much more faster, associated technologies can evolve with much faster and in surprising ways of what they can add to capability. So it's a whole new frontier of all kinds of complex turns and potentials to explore. So how do we get the realization prevalent in our society that there really is significant improvements in that important collective capability to be had? Very, very important improvements. And that they're really potential. Gosh, it's important to society, hugely important. How do we get going after them? How do we wake up the world about it? It's your fault. The ownership of a problem is a very significantly different thing from the ownership of its solution. And yes, that sort of factor really comes into this pursuit of augmenting this collective capability to cope with complex problems. And the ownership of a lot of the solutions can get into real problems as they get mixed in with ownership of the problem. And thus one comes about of saying, how might it get as we start developing, extending our vocabulary, our natural language vocabulary about how we talk about the ways and the means and the expressions and the processes and the methods, that if that vocabulary gets tied up with proprietary things such that, oops, you can't use that verb because I have it patented. You can imagine what a terrible containment that would be in the evolution of our thinking in our world. So we have to be careful about what it is that we tie down with proprietary means, so that we don't hobble ourselves. And there's some quite obvious things in our current emergence of our ways of using computer technologies to facilitate our system. How do you take that complexity and the scale of all the factors and have a strategic path to follow that gives you the best chance to make the headway you need? This strange thing called a hyperscope. It came out of that strategic thinking that, hey, there are guys I know that, well, our friend Ted is just so convinced that if you took his zigzag and plug in, it'd be the answer to all. Well, you're going to plug in, it's going to take a lot of change. It may well be, but no one can make that abrupt change. No one can change their whole organization's way of doing their knowledge work and replace it with that. So how do you set up an evolutionary staging that can introduce that? Well, that sounds as saying, hey, there must be a more effective way to try to get people thinking and really seriously considering that there really could be a lot more collective capability.